Hello everyone, this is Dr. Mike from Oxbow Meadows, and today we're going to look a little bit about water, and specifically, where is all the water on our planet located? There's a handout that goes along with this video that your teacher may have provided to you that has a chart, a very simple chart that asks you to estimate the percentage of water in different categories. And the categories we're going to try to assign that percentage to include the oceans, what's frozen, such as glaciers, what's deep, deep underground that's hard for us to reach, what's available for us to use as drinking water and other water sources. And then we're going to have another category just called other. What other places might you expect to find water on our planet? So I want you to make an estimate of each category, and the percentage should add up to 100. And after you have finished that, you can return to this video and we will continue. See you in a minute. Welcome back. So now that you've made your guesses, we're going to look at a little demonstration. That demonstration is going to use 1,000 milliliters of water that is colored blue, and we're going to place it in different containers representing those categories that you just estimated. And we're going to try to see exactly how much or what the percentage looks like of water and how it's distributed on our planet. Watch and see how close you were to your estimations.
Pretend like all of the water in this jar is the water on our planet. We're going to demonstrate where water is found on our Earth. Here in this jar, I have 1,000 milliliters of water with some blue food coloring. For this model, we're going to use our water table. If you haven't already, please look at your water table chart to see how water is distributed on our planet. If you guessed that most of our water on our planet is in the oceans as salt water, you're right. Over 97% of our water on our planet is in the oceans as salt water. Is this water that we can use in our everyday life? Of course not. The reason that we can't use this water as drinking water or accessible water is because it's full of salt. Where else is water on the planet other than in the oceans as salt water? Where else on our planet can you find water? If you think of the North and South Pole or the Arctic and Antarctica, you may have thought of all of that ice. Those glaciers is frozen water. Frozen water, of course, can't be used or accessible to us to use in our everyday lives. So this water is frozen. It's in a different state. It's in its solid state as ice. These ice caps and glaciers make up 2.2% of our planet's water. What is 2.2% of 1,000 milliliters? 2.2% of 1,000 milliliters is equal to 22 milliliters. Let's go ahead and pour some of our Earth's water into that beaker there. We're going to pour in 22 milliliters. If 97.1% of our water plus 2.2% of our water is in the oceans and frozen water respectively, how much water is left from our 1,000 milliliter Earth in our model? Well, if you remember, 1,000 milliliters minus 971 milliliters leaves us with 29 milliliters. If 22 milliliters of that 29 milliliters is frozen or inaccessible, that only leaves us with 7 milliliters left. But those 7 milliliters are not accessible to us here at Earth, so that 0.7 is still not water that we can drink. Let's find out where some of this water resides on our Earth. Did you know that deep down below our Earth's surface, down below the rocks, the soil, there's actually water? That water is sometimes in aquifers and is called groundwater. That groundwater is deep down in the earth and it is difficult to access. 0.3% of our water on our planet is our groundwater. What is 0.3% of our 1,000 milliliter model? Three milliliters is equal to 0.3% of 1,000 milliliters. That means that we have 3 milliliters in our deep groundwater in our model. So now altogether in our oceans, our frozen water in the ice caps and glaciers, and in our deep groundwater and aquifers and that water deep below our Earth's surface, how much water do we have left from that 1,000 milliliters if we've used 3 milliliters, 22 milliliters, and 971 milliliters? If you did your math, then you know that we have 4 milliliters left from that 1,000 milliliter water source of all of our Earth's water. The accessible fresh water that we have on our planet is 3 milliliters. It's 0.3% of all of our Earth's water. That leaves us with 0.1% left, or 1 milliliter, of other water sources. What could that mean, other? What types of water might fall into this category? For that 0.3% or 3 milliliters of our actual drinking water that we have on our planet, of that 3 milliliters or 0.3% of our accessible fresh water, meaning water that we can use for the things that we use water for every day, where is that water contained? Even though we only have 0.3% of all of the Earth's water on our planet as accessible fresh drinking water, you shouldn't be alarmed. And the reason for this is the water cycle. Our water, our fresh water, is recycled through the water cycle through processes like evaporation, condensation, precipitation, and collection into bodies of water like lakes, streams, rivers, and even ponds. These are different sources of fresh water that we actually have access to or we're able to use for our everyday drinking water for our lives.